Let's take a look at problem number 20. So 12 of King Arthur's knights are seated around a circular table. Given that order is not important, in how many ways can King Arthur choose 3 of them such that no 2 chosen knights are seated next to each other? So let's start by drawing a diagram just so it's easier to visualize what's happening. I'm always a big supporter of drawing diagrams because visualizing everything in your head is hard and makes your head hurt, and that's not fun. So we have 12 knights, right? And King Arthur needs to choose 3 of them to, I guess, send on a mission. So if there were no restrictions, the number of ways in which this could be done is 12 choose 3, which is 12 times 11 times 10, all over 6 factorial. Not 6 factorial, 3 factorial, which is 6. And that gives us 220. So that means our answer cannot be more than 220. So that's always a good sanity check, right? And that's also why at the beginning of many of these problems, we start with like the upper bound. Because if somehow we get that King Arthur can choose knights in 9,000 ways, well, something probably went wrong. Or maybe you're dreaming. Who knows? So we need to figure out, right, how many ways do not work. Right. And there are 2 cases that do not work. Note that our main condition is that no 2 chosen knights are seated next to each other. So we have 2 ways that would be violated. Way number 1 is if all 3 are together. Well, if all 3 are together, right, then we're just looking at a block of 3 of them. And there are 12 places where that block could start. So that's 12 ways we have to subtract out. Nice enough. Okay. Our second way is a little more complicated, though. The second way is that we have 2 together plus 1 separate. So this still doesn't work, right? But it's a different case than all 3 together. So how many ways do we need to subtract out from this possibility? Well, the number of ways to pick 2 knights that are together is still 12, right? It's just 2 consecutive knights, and it could start at any one of the 12. There's 12 ways to do that. But then how many ways are there to choose that last knight that's not together? Well, let's think about it. We know that that final knight can't be 4 or 5, obviously, and it also can't be 3 or 6 because then they'd all be together, and that puts us back in case 1. So we don't want to overcount. So therefore, the last knight has to be in one of these positions over here, and there are 8 possible places where that final knight can be because, well, 12 minus 2 minus 2, or just count to 8. So therefore, we have to subtract out 96 ways from this second case, right? And therefore, right, the total number of ways in which King Arthur can actually choose his knights so that no 2 of them are seated together is 220 minus 12 minus 96, which is 212 minus 108. 220 minus 108 is 112. And that is our answer for number 20.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.